Yeah. All right. Hi, everyone, and welcome to the talk. Thank you for coming. It's really nice to see so many folks like really interested in rigging and animation in Engine. I hope you've been enjoying the beautiful Gold Coast. It's absolutely stunning here, right? My name is Matt Ringo. I am a senior technical animator at Epic Games. And today we're going to explore the power of Control Rig for animation in Unreal Engine 5.4. I'm going to make a very brief introduction. I am French, but I've been living in New Zealand for quite some time now, about 8 years. I just want to apologize now about my weird accent. I know, sorry. Okay, French, Kiwi, Freewi. It's going to be all right, yeah? Yeah? There might be some French words here and there, but no. I'll do my best to be clear. Okay, so I have studied and started my career in France and briefly moved to London to actually work into the visual effects industry. After a couple of years at MPC London, I relocated to New Zealand in 2016 to be joining the Weta FX Creature TD team. In 2021, I opened Unreal and Control Rig for the first time, so pretty new here, and made a T-Rex rig in a few days. I absolutely fell in love with Control Rig at that time and never looked back since. That's why I'm here today, right? This little side project gave me the opportunity to join the awesome Weta FX special project team, where I was able to work on some real-time projects such as the Big Bot demo for the UEFN last year in collaboration with Epic, and also the recently award-winning short film, War is Over. There's awesome 2 talks tomorrow. Don't miss out. They're going to be great about this short film, so go for it. I joined Epic last October to be part of the awesome Take Anim team on LEGO Fortnite. All right, so I'm actually super excited to be here today and to be able to share some of the cool stuff we've been up to. As you know, rigging and animation in Engine is a real focus for Epic. And today, I want to share a few tricks on how you can empower your rigs with Control Rig and make the best rig for your animators, all right? We have a lot to cover, actually, so let's just dive in. All right, so the power of Control Rig and how to make those rigs amazing for your animators. As a rigger or a technical animator, we do have to think a little bit differently using Control Rig. And this starts by forgetting the dependency graph node. So Control Rig is based on an event stack and not a dependency graph node, which basically unlocks tons of possibilities, all right? On LEGO Fortnite, we have quite a few creatures with off-plane limbs, which makes the IK solve quite interesting. I'll get to that in a second. Here, I'm basically using a slightly modified robot leg to demonstrate the issue, or let's say, the challenge, all right? Cool, but what do I mean exactly by off-plane leg? When we look at this robot leg, looks pretty standard to me, right? Well, a standard planar IK will basically, most of the rotation will happen in the upper part of the leg. The knee will rotate in a single axis, and this would work well if the 3 bones are in the same plane, as demonstrated by this blue line here. Okay, that's cool. What about we try to solve our robot leg with this standard planar IK? Yeah, I mean, doesn't look too good, does it? If we start looking at our little hip articulation here, we're breaking the model pretty quickly, right? And we don't want to go back to our modeling team and say, hey, can you just put a ball joint there so I don't have to do some fancy rigging stuff? No, we like the challenge, right? So what we're going to do here is we're going to try to solve this leg with the joint in the hip area, okay? And that is basically an off-plane limb. One of the joint of the leg is off the plane of the leg. And why is this that challenging? Well, let's try to just solve with a standard planar IK this leg, this off-plane skeleton. All right, the hip area looks much better. I quite like it. But if we look at the knee, right, we can see that this is rotating in 3 degrees now. And it's actually breaking the articulation. So this is not a valuable solution, okay? So what's the challenge here? Basically, we want to make sure we're not breaking the model, okay? We want to make sure that the angle between our upper leg and our ankle is locked and maintained at all time. And we want to make sure that the knee rotates in a single axis and keep the articulation nice and easy. All right, cool. So what would you do typically in other DCC or other applications? Potentially, you would create a separate chain. On that chain, you would create your IK solve, and you might be doing like a bunch of extra rigging on top to make it work with your off-plane skeleton. And that's fine. But in Control Rig, what can we do? Well, we can do something way nicer in just a few steps, a very simple math, no extra rigging, we'll be able to solve this kind of complex issue. So let's dive into the graph. The first thing we are going to do, before I hit play here, is we're going to solve the upper leg, or the leg, sorry, from the upper leg to the ankle. But we saw that on the first slide. This is actually going to break the upper articulation, right? But what we're going to do is we're going to create a transform at the original hip location. And we're going to parent this transform under the upper leg, okay? This basically makes sure that we're maintaining the angle, or at least we have somewhere a transform that maintains the angles between the upper leg and our hip location. Okay, sweet, that's step one. On step two, that's the angle. On step two, what we need to do now is, because we know that we have maintained our angle and we know exactly where our hip's supposed to be, we're simply gonna shift our whole leg up, right? So we simply shift the whole leg up to the original hip location. But as you can see here, and that's the, oh, I should have not clicked that one, sorry, come back. This is not working. I should point over there, I think that's what it is. There you go, coming back. Okay, I'm gonna get to there. Sweet. Okay, so we're shifting the whole leg up, sorry about that. So trying to figure out how this thing works. And that's step two. Okay, so shifting that up, sweet. But what we can see is basically our ankle, which is our result, right? The result of our solve, and our IK, which is our goal, are not at the same place. So this is not a valuable solution. We can't really give that to our animators and say, yeah, just animate that. The geometry will be off your IK control, but it's all right. So what we want to do is potentially try to get closer to the IK control. And what can we do to do that? Well, we're going to calculate two vectors. One from the hip location to the ankle, and one from the hip location to the IK control. And between these two vectors, we're going to calculate a rotation delta, and we're just simply going to apply this rotation onto our hip joint. Okay? Pretty cool, yeah? We're getting closer, still not quite there yet. So 3 steps. What's the 4th step? Okay, let's move on. 4th step. We're going to try to solve the IK again from the upper leg to the ankle. But does that ring a bell? It's actually step 1, right? So we do this, we're reaching our goal now. That's great, awesome, I'm happy. Oh, wait a minute. Actually, no, I'm not. I'm breaking the upper leg angle again. So we're going to do step 2. Pretty simple. We're going to shift the whole leg up. We've done that before. All right, let's do step 2. Sweet. I'm good. But while we are at it, we might as well do step 3 and get even closer to our IK goal. Okay, so now we're going to do step 3. Snap this bad boy. Awesome. Perfect. My IK control, which is my goal, and my ankle, which is my result of my solve, are exactly at the same place. It's pretty clear now that we're using very simple steps, 3 steps, but we're using them a couple of times, okay, to reach our goal. And obviously, this is with 1 iteration, so we're not actually on the spot. And with the second iteration of our 3 steps, we're exactly where we need to be. But obviously, we don't want to duplicate that whole logic multiple times. And some poses might require more iterations as well. More complex poses might require 3 or 4 different iterations. And that's where iterative functions come into play. In Control Rig, we're able to create a function that would potentially take a maximum iteration, maximum number of iteration, and a tolerance. Pretty straightforward there. What we're going to do is at the end of every solve, at the end of every of our 3 steps, we're going to check the distance between our ankle, which is our result, and our IK goal. If the distance is within the tolerance, we don't need to iterate anymore. We already reached our goal, or we're close enough. But if we are not within the tolerance, we need to keep iterating. So that's at the end of our solve. And at the beginning of our solve, we're simply looping through the maximum number of iteration, and we're checking if we need to keep iterating or not. Awesome. Well, what we can see here is some poses might require 2 iterations, some poses might require more, like 3 or 4. But typically, iterative solving is something you'll not be able to do in a dependency graph node without writing your own custom nodes. We've basically solved a complex issue with very simple math, only 3 steps, no extra rigging, no extra chain required, okay? And on top of this, we're saving performances because as soon as we've reached our goal, we're stopping iterations, right? And that's quite important as well. And that takes me to my next subject, performance-driven rigging. So it's fairly known that Control Rig can be used at runtime for your games, yeah? And this is a great example, actually. I don't know about you, but I love Colombo as my favorite character. Look at him, so cute. I'm a cat person, so I always imagine him like running around, like, come here. Anyway, yeah, so it's a great character, and here basically a great example is slope warping, right? Where the character will adapt its feet and body positions based on the uneven ground, okay? The thing, though, is with runtime control rig, they need to be extremely performant, all right? And they need that, especially if your game is running on multiple platforms, right? Lego Fortnite runs on so many different platforms. We need to make sure our rigs that are running runtime are doing great performance. Okay, so the rig VM is actually really fast, right? But if you have a very low performance budget for your runtime control rigs, converting your graph functions to C++ is a valuable solution, all right? And to do so, it's actually pretty easy, honestly. You have access to the Unreal source code. You can look at all the different rig units that are available in control rig, and you can make your whole way through, you know? It's super nice. So here, I just wanted to see how much performance gain I could get by writing the iterative solve into C++. And since a character could have 2, 4, 6, or 8 legs, you know, we could get a pretty decent performance gain, right? So using the built-in profiler in control rig, I am able to clearly see what's taking the most time to evaluate within my graph. The colors are changing based on the graph view, which is pretty awesome. And on top of that, I can also display the node count on each node. So I'm sorry, it's pretty small here, but check that. So here in the settings there, you can set the node count, which is basically the amount of time that node is run on every tick. And it's actually super satisfying for a tech animator to make your rig more performant without affecting its behavior. I don't know about you, but I just love this stuff. So here we're comparing basically the graph function of the iterative solve, which for this specific pose run at about 60 microseconds. And we're comparing it with the C++ functions, which runs at about 10 to 16 microseconds. There's quite a big difference there. A few improvements were done in the C++ function that weren't in part of the graph function, but we do think that there's about 3 to 4 times faster in C++. Wait here. I am not telling you that you should convert all your graph to C++, okay? This is a very specific case. This is for runtime control rig. The rig VM is extremely fast. And for us, it was great test case, you know, and see, okay, that is an option. And especially for characters with more than 6, 8 legs, it's awesome. So that's a great option. And I want you to consider it. All right, so my next subject is data-driven rigging. So I'm just gonna have a sip. And data-driven rigging is extremely powerful. It's where a single control rig can drive n number of skeletal meshes, okay? It's basically, it will adapt its requirements. It will adapt the number of controls, it can adapt the control shapes, it can do basically a bunch of things. So here we have a single prop rig, and every time I drag and drop a different skeletal mesh on top, it will create new controls. It will adapt the control shapes for it. So for Lego Fortnite animators, they love us, okay? The thing is, with all these control shapes libraries, they basically have the feeling to animate real Legos. They're playing with bricks, right? It's super cool. And for us, tech animators, this is a dream, okay? We have one single place to make changes. We don't have to, when we want to do a change to the rig, we don't have to go through and do a batch publish of all of our assets with different geometries and different number of controls. No. Everything is in that single control rig. We do one change, we have more than 100 props, right? So this will propagate automatically on all our props. And that's a big win for us. And how do we achieve that? Well, we can use asset user data. In our skeletal meshes now, we are able to specify in the asset user data a couple of things. And here, for example, we're using the control shape rig library link right there. And basically, here we're specifying the control shape library that we created. And every time we're going to drag and drop a new skeletal mesh, our rig will adapt its control shapes. Pretty easy. And the second thing we're doing then is in the construction event of our control rig, the first thing we have to do is import the skeleton, that basically is, it will make sure that the hierarchy gets updated every time you drag and drop a new skeleton, okay? When you change the preview mesh, you want the whole hierarchy to update, so that's the first thing. And the second thing is we're setting the shape library from the user data. and here we can do whatever we want with our controls. So that's a pretty generic example. But what if I tell you that this single control rig here can also drive those three very different assets? Yeah, we have March that has 4 arms and tail. We have a standard biped, and we have also a robot that has no hands and is probably 4 or 5 times bigger than a biped. Well, for this, we're going to use primary data assets. And here, it's a simple blueprint that inherits from the primary data asset class, and we are able to create a couple of variables within that primary data assets, which will be called control scales, the arms number, if it has hands, legs, or, tail. All right. Once we have this, we can create 3 different data assets, one for each of our skeletal meshes, okay? And there, we can specify specific settings for each. So, when we'll have a control scale of 2, for March, it will have 4 arms, no legs, but it will also have a tail. Standard biped is a standard biped, and the robot will have a control scale of 4, and also no hands. All right. Once we're done with this, we simply have to do the same as what we've done with the control shape library. We go into the skeletal mesh, go into the user asset data, and we specify a data asset link, where here we're able to specify each of our data assets. Pretty straightforward so far. Now, in control rig, very simple. In our construction event, first thing again, we import the skeleton. And the second thing then is we're querying the data assets information, all right? So we're using the get user data rig unit here, where we can get each of our variables, store them into local variables within our control rig, and do anything we want, right? We can drive some rig logic, or we can spawn a certain number of attributes, or spawn a certain number of controls. And that's pretty cool, right? So the rig will adapt to each of the characters, and it's a single place to make changes. And I think that already is a big selling point. Like, I hate it. I used to work in the visual effects industry, and when you do one change to a core, rig, and you have to republish a bunch, it's just frustrating, right? So here it's pretty cool. Okay, so one awesome other way to empower your rigs is the use of control interaction. And the tech team lead on Lego Fortnite, Jérémy Passerin, came up with a very cool solution for live IK-FK matching. So what is great here is our animators love it. Basically, you can animate in FK and in IK mode at the same time. You don't need to switch between mode. You have access to FK and IK controls to pose your character at any point. Both of them will be keyed, and that's super nice. So we're going to dive into the graph because I think it's quite a cool example here. And the first thing we have to do is we have to define the active mode, okay? So pretty straightforward. We have this get interaction event rig unit, and here we're checking, hey, am I interacting with IK controls or FK controls? When am I interacting with IK? I am simply setting a solve IK-FK variable to true. And if I am interacting with FK controls, I'm setting these variables to false, okay? That's pretty simple. This is just a custom event that is running on the forward solve, so on every tick. Here we can see the graph in action. So when, if you follow the white line a little bit there, probably a bit small for you guys, sorry, but here you can see that when I'm interacting with IK, it's setting these variables to true, and when I'm interacting with FK, it's setting it to false. Pretty easy. All right, so then we move to the forward solve. And this, I know, it's a bit scary, don't worry. It's decoupled in 4 sections. We're going to go through that pretty quickly. Ooh, fancy transition. Yeah, didn't expect that one. Okay. All right, so here, basically, we're checking our variable. Yeah, and our variable says, okay, I'm interacting with IK. So when I'm interacting with IK here, the first thing is I follow this line, and the first thing I have to do, I am moving my IK control. So my bones stay here, my IK controls move. I need to solve the IK. So I need to do the 2-bone IK solve to solve my skeleton, so then it's on the IK position. And the last thing we're doing here is simply making sure that the last bone of our IK follow is the same rotation of our IK control. Straightforward. But once we've done this, okay, we have our IKs that way, we have our skeleton here, it's cool, but our FK controls are left behind. So we need to make sure our FK controls are following as well. So what we're going to do is we're simply going to go through our bones, and we're going to get their transform, the transform of each bones, and set that onto our FK controls. Done. So we moved our IK, moved the skeleton, our FKs are following. Great. Now, when we're interacting with FK, we need to do the opposite, okay? So the first thing we're doing is we're moving the FK control, rotating it, sorry. And from that, we need to solve the FK joints. So we get the transform of each of our FK controls, we're setting that onto the bones, and they follow. But here again, the IK controls are left behind, right? So we need to do an IK match. And here, pretty straightforward, we're getting the last transform of our bone, yeah, and we're setting that onto the IK control. And after this, we're just finding the plane of our arm or leg, and we're finding where the pole vector is. Done. Cool, we're done, right? Looks nice. Well, not quite. There's actually two things that are quite important to do to make this setup work. And the first one is, remember when I say, hey, I move my IK, I need the FK to follow? Well, they also need to be keyed, right? So when I'm actually moving the IK, I want the FKs to have keys as well. And when I'm moving the FKs, I want the IKs to have keys. So in our construction event, we are going to specify driven controls, okay? And here, basically, we're simply looping through the FK controls, and we're saying the IK controls are your driven controls. Sweet. We have to do the same with the IK controls. So we're looping through the IK controls, and we're saying the FK controls are the driven controls. Sweet. And the second thing that is quite important, it is actually very important, is to create an IK interpolation attribute. So yes, your animators don't have to switch between modes, but you still want to give them the capacity of choosing in which, how the keys should be evaluated, right? The interpolation. So in this case, we create a IK interpolation attribute that is going to be on the IK control. And this is used in the define IK-FK interaction event at the beginning, okay? And to demonstrate this, here basically I'm moving the IK control, and you can see it's actually creating keys on all of my controls. So that's what I want. And if we look at the blue line here, which is a linear interpolation, and when I switch this attribute off, we can see now we have an arc to our motion. And this means that we're evaluating the keys, interpolating the keys in FK mode. But I'm still able to take my IK control there and pose my leg, even if technically I'm in FK mode, all right? And that's amazing. Animators love it. This is so cool. So you can very quickly switch back to IK by turning the IK interpolation attribute to true, and then you have a linear interpolation, as demonstrated by the blue line here, and now the red line, which is FK. Sweet. Another awesome way to empower your rigs with Control Rig is the use of proxy controls coupled with interactions. And you've probably seen the awesome box rig from Jeremy Passerin as well. Basically, proxy controls are non-keyable controls, all right? They won't be visible in the sequencer, but they allow you to manipulate other controls and key other controls. So here, for example, the proxy calculates the pivot on every tick, and will rotate and translate the body of the box, right? The body control around that pivot. All right, see you box, have a good one. Cool, so our animators came to us and say, hey, I would like to have two proxy control, one under each foot that will drive the body control so I can do some weight shifting easily. Sure, super easy, right? With Control Rig, proxy controls, nice and easy. But we say, wait a minute, can we make this even cooler? Can we give you a proxy control that you can move anywhere you want, at any point, without breaking the current pose? And that's pretty cool. You can't do this in other DCC without running scripts. So here we have basically a movable proxy control that can be moved at any point, right, during your animation. And it will drive our body control there. So pretty awesome. So I just want to go through how we're going to do this, okay? And we're going to create two simple functions. One that will be used at the construction script and one that will be used at the forward solve. So the first one here, it's going to get bigger. We're going to spawn a hierarchy here. So we're going to spawn an offset, the proxy, and the buffer. We can totally do this with just math, okay? I just wanted to make sure that this was a bit easier for the graph and make it a bit more readable. So the first thing we're doing is we're spawning our parent here, which is our proxy offset, and this is just a null. So think about it as a locator, you know, or a group transform, right? Once we have that, we're going to spawn our proxy control. In our proxy control, we have to define two very important things. The first thing is that it's a proxy control. Well, yeah. So here, we can, in the spawn rig unit, we can specify that it is a proxy. And on top of that, we have to, do you remember when I said, hey, the animators want those proxy to drive the body control? We need to specify that at some point. We need to be like, hey, proxy, you're actually driving this control. And that's why we're doing it. When we're spawning the control, we are able to set the driven controls. You have two ways to do this. Either you do it in the spawn transform control rig unit, or you can also do it using the set driven controls rig unit if your control is already spawned. And the last thing we're doing is we're spawning the child here of our proxy control, which is our buffer. And also we're creating a isBuffer set metadata. I'll get back to that in a second, but that's going to be used in the forward solve. All right, our construction function is done. We can put that in our construction. It's going to build this little hierarchy here. Very nice and easy. Now we're moving on to our forward solve function. And this will be decoupled in 3 different sections. The first one is we need to define the interaction. We need to know if we're interacting with the proxy control or not, right? So we're using, again, this interaction rig unit, get interaction rig unit. And also what we are checking here is, are we rotating this proxy control? We're not really interested in the translation right now. The only thing we can do, what we can do is everything with the rotation. So if we are interacting with it and we are only rotating with it, the first thing we want to do is snap the buffer, which is the child of our proxy, to the body control, okay? But we want this to happen only once. We want this to happen only once at the beginning of our rotation manipulation. Okay, so to do that, we're using this little trick with the metadata. And what it's going to do is it's going to check if the metadata is set to true. So is my buffer set? Has it been snapped already? Yes or no? The first time, it won't be. So it's going to go through this graph, and it's going to get the transform of our body control, and it's going to set that transform onto our proxy. Right? Pretty straightforward. But what's happening next is I start rotating my proxy. I snap my buffer to my body control. And when I keep rotating my proxy, my buffer, because it's the child, will simply follow, correct? So what we need to do next is simply snap our body control back to our buffer. All right? So we get back to the graph. We've done this upper part here already. And then here, we're simply getting the transform of our buffer and setting that onto the body. Pretty easy. Done. Basically, we now have that proxy control animating our body. But what we can do as well, we want this proxy control to follow the rig nicely. So there's a couple of things that we need to check is when we're not interacting with it, we have to reset some states. So here, we're just checking earlier here that if it's not interacting, it goes to false here. And basically here, what we're going to do is we're going to parent we're going to snap the parent of our proxy control to whatever bone or control we want, okay? So then it follows the rig. The second thing we're going to do is we're going to set the body orientation or the driven control orientation to our proxy to make the next rotation manipulation easier because the proxy control will be in the same orientation of our driven control. And the last step to not forget is to set the metadata to false, okay? Remember, we want this to happen only once, but when I'm not interacting with it, I want the next iteration, the next time I grab my proxy control and I start rotating it, I need that buffer to be snapped onto our driven control, okay? And that's what we're doing here. So we're setting that to false, so the next evaluation, the next manipulation, we're making sure that we're snapping it. All right, guys, with these 2 functions now, we have created a movable proxy control that would work on any rig and any control, okay? Using the body weight was a good example, the body weight shifting. But this stuff here is used on a simple prop rig. And what you can see here actually is we actually breaking a direct cycle, okay? The basket is driving the proxy control. The proxy control is driving the basket. That's amazing. You know, we're not running any script, nothing. So this is just using interactions and proxy controls. So your animators can place this pivot wherever they want and rotate the actual basket control around that pivot. That's super neat. And playing a bit more with interactions, we wanted to do a kind of a bidirectional spine on Lego Fortnite without breaking the model. And this is like you can pull any side and the whole model would come up, okay? So it's pretty cool for quadrupeds. When they change in directions, for example, the chest is going to come forward first. But then if they're moving backward, you know, the hips taking the motion there. So you can pull in both sides, both directions. There's only 3 controls there, and they all get keyed at the same time when you're moving them. So pretty awesome stuff. All right, so obviously you know that rigging and animation is a real focus for Epic, yeah? And there's a ton of awesome tools coming up in 5.4, so I just want to go through some of them. And the first one is a layered control rigs, okay? And that's for animators out there. It's a non-destructive animation workflow where you can add or animate on top of the incoming motion without having to bake anything into your controls. So here, I have a robot with a couple of animation sequences, animation there on the track, and what I'm going to do is simply add a layered control rig on top. So layered control rig will run the backward solve and the forward solve live on top of your incoming motion. And here, I'll be basically able to author the animation very simply, okay, and very quickly with just a couple of keys. So now you see, there's no keys here, and the rig is following nicely, okay? Now, I didn't quite like the hover. I had a hover animation, and it's not really going too much high in the sky. So I just wanted to edit that little part. So I'm just grabbing the body control and moving my robot up a little bit and down and making a couple of keys. All right. And here I'm able to just see the animation that I've just done by muting the tracks. That's pretty nice. And what I can do now as well is I want to shift the hover. I want it to be shorter. The animation's too long. I can simply shift my track. I don't have to deal with tons of keys. I don't have to go through and like clean everything up. I shift my track. I go back into the animation. I have 2 keys to deal with. Pretty nice, right? So we have 2 new shortcuts, Control-I to reset the pose to the incoming motion, and Control-G to inverse, basically, the coming motion and to return to the default pose. It's pretty handy when you're selecting a couple of controls and you want to make sure that you removed your current animation. So now, imagine that you're running facial solve using the awesome facial animator, MetaHuman animator facial solve, yeah? And you simply want to edit this animation, right? But you just have to add a layered control rig. You don't have to deal with tons of keys. It's a dream. It's pretty nice. So layered control rigs are extremely powerful, and we have more examples in the content example projects. And one of them is using constraints. And I want to touch base about constraints because Benoit Gadreau and Michael Zierke from the sequencer team have done an amazing work to make them more user-friendly and stable. So constraints have a bunch of new settings. The data model has been rewritten completely. They're now saved in the sequencer, which makes things nice and tidy. We still support level constraints, but only if the sequencer is not in use. And here, basically, I'm creating a look-at constraint from the torso to that sphere. And I am able to animate my rig with a control that was not provided by the rig. And that's pretty neat, yeah? The other thing I can do is I can bake this animation back onto my rig. So I'll simply go in here and bake the constraint down, and all the keys will be back onto my spine control. Now the sphere is not affecting my rig anymore. And I only have a few keys to deal with, which are all on my spine control. But doing so, we are losing the incoming motion. As soon as I start a look-at constraint, I create a look-at constraint from my torso to my sphere, whatever was the animation on that spine 3 or spine control is gone, right? So what about I want to preserve the initial animation, but still animate a look-at sphere? Well, what we can do is we can create a parent constraint from the torso to our sphere. Simple. And then we can bake that constraint down. So now we have keys on our sphere. So we can recreate a look-at constraint and not damage the incoming motion, okay? So now we have an incoming motion. We still have the look-at constraint. Oh no, we're going to create the look-at constraint in a second. Awesome. And what I can do now is either add an additive layer on top and animate on top, or I can easily go into my sphere animation and just delete a few keys and reanimate the end of our motion. So that's pretty nice. We save the incoming motion. That's cool. Easy, all right? So the fact that, yeah, constraints are saved in the sequencer makes them very nice and tidy, and it's really easy to turn them on and off as well. One huge addition to 5.4 is modular rigging. You've probably seen that, a couple of videos. There's so much cool stuff out there at the moment about it. It's pretty hyped up. So modular rigging utilizes the entire control ring framework. You can create your own modules. You can drag and drop them onto your skeleton, and you can basically rig a character in a few minutes and play with it. And that's pretty amazing. We have a couple of examples modules in 5.4 made by our awesome Chase Cooper. Those modules might not work with every skeletons and all the creatures in the world, but they're awesome examples to dig in, right? The thing is, this tool has been made extremely flexible. We want you guys to get your hands in there and build your own module, okay? So here, in just a few minutes, I'm able to rig this character and just play with it. The awesome big bot from the UEFN demo last year. And those modules have a bunch of exposed variables as well, where you can change the size of the control, the shape of the control, or whatever you need. So today, I want to build two modules with you guys, a root module and an FK module, okay? We're gonna make them flexible. We're gonna make them working with drag and drop. And they're gonna talk to each other using module metadata. And on top of that, we're going to expose a few attributes at the top level so we can change the color or the shape of our controls, okay? I just wanna say, there's no right or wrong way to build a module, okay? This tool, again, has been made really flexible. In this example here, we're not gonna use sockets. Most of the example modules are using sockets. I just wanna show you different options, okay? Just before I keep going there, I'm gonna warn you for a second. It's gonna be a couple of slides coming up. So take a breath, shake it up, and we're good, all right? Let's do it together, we'll be good. Okay, so the first thing we're gonna do is we're gonna create a standard control rig. And on that standard control rig, we're gonna name it correctly, all right? Root. And we're gonna set the preview mesh. And the first thing we're going to do at the top there is we're going to switch it to rig module. This is new, and that's going to create a primary connector. This primary connector, we're dragging and dropping it on the root, and then we're creating a bunch of variables because we want to make sure that our rig is clean, right? So the few variables, it's going to be, one's going to be called root joint, the other one's going to be called the global control, and the just rig element keys. And the last one is the global control shape, which is a shape setting variable. And that's where you can expose that by just clicking that little icon here to make it public. And so you can change the shape and the color of your global control. Okay. Now, this is the solve for the root module. It's pretty straightforward. Don't worry. I'm going to go through that pretty quickly. You can obviously make this very much more complicated. We're just taking a simple example here with a single control. Okay. So the first thing we're going to do is we're going to set the root joint variable that we just created earlier. But this root joint variable here, we're not just setting it saying, hey, this is the root joint. No, we're actually querying the information from the connector, which is the new stuff in the modular rig. Think about connector as a tag or a placeholder for the data you want to use. So here we're saying, hey, root connector, can you give me the joint that is resolved to you? So in this case, it's the root joint. We're setting that into the root joint. And we're spawning the global control. Pretty straightforward. And the next step here, which is actually the first step to get our modules to talk to each other, is using module metadata. So here, I'm creating a metadata called global control on our current module using the namespace self. And the value of this metadata will be our global control item. Okay? The idea is, in another module, I can go, hey, metadata, can you give me that global control that is referred somewhere? And I don't need to expose this global control to each module. I don't need to keep, it's just there in that metadata. It's stored, I can just query it at any point and get the actual control. That's awesome. Last thing we're doing is we're spawning a little control visibility attribute on our global control. So think about it as any kind of settings you will set for your animators. Let's say you want to hide the face controls or, you know. So here we're just setting control visibility attribute. All right, so what we have now is we have a global control, a control visibility attribute, that's cool. But we need to make sure that when we're moving this control, the skeleton is following, all right? So that's going to be the forward solve. And in the forward solve, well, pretty simple, we've done that before. We're getting the global control transform, and we're setting that onto our root joint. Nice and easy. And the last thing we're doing is we're creating a new metadata called control visibility. And here, actually, we're querying the value of our control visibility animation channel, and we're going to set that into that metadata. And here, again, it's the same idea, right? In another module, I come in and I'm like, hey, I need to drive the visibility of my current controls in that module. Just give me the metadata that's supposed to be connected to it. And I don't need to expose this to anything else, all right? So that's awesome. Sweet. Root module is done. Moving on to the FK module. So here again, we're creating a standard control rig. We're setting the preview mesh. And we're going to switch it to rig module at the top there, over here. This creates the primary connector. We're going to drag and drop that onto the spine 01, and we're going to rename it start connector. We're going to create a secondary connector on spine 04 or 05, and we're going to call it end connector. Okay? Cool. This is a little special here. This end connector is going to be optional. I'm going to get back to that in a second, but just remember we've set it here to be optional. And then we're going to create a bunch of graphs because we like it clean. So obviously we need a construction event, a backward, backward construction, forward, and obviously a new one now that is a connector event. And this is going to be to solve the drag and drop, basically. When you drag and drop your module, you want it to auto-resolve. So we're going to get to that in a second. So here I'm creating a bunch of variables, bones, controls, array, an FK parent, which is where our FK will be parented under, and also the FK control shape, where we can then set it to public so we can change again the scale and the colors of our control. All right, we're getting to that. All right, cool. Now, what we want to do is, as I said, is solve this drag and drop feature. Okay, and that's with the connector event. So here you can see I'm dragging the primary connector, but the end connector automatically finds where it's supposed to go. Okay, I don't have to specify it. And that's how the drag and drop works. So to do so, we're using the new connector event. And this connector event runs on every connector. Okay, so here what we're doing is we're checking if the current connector the event is run on is equal to our end connector, because that's the one we want to auto-resolve. Okay, and if it's the case, well, we need to grab the start connector, we need to find all the children of this start connector, and we need to take the last child and set that to as a default match to our end connector. Okay, so think about it. You drag and drop your primary connector on tail 01, you want the end connector to automatically find tail end joint, and then say, okay, I found the one I want. You can also override this in the modular rigging system, which is fine, but it's kind of nice to have a drag and drop feature. So here we're already getting the drag and drop feature working. That's nice. Okay, now moving to the construction graph. 2 sections. The first thing is we're going to define a few variables. And what we're doing here is, remember when I say, hey, this connector needs to be optional, what we said here? Okay, that's actually quite an important aspect of rigging with modules. So here what we're doing is we're saying, hey, connector, are you connected to anything? If you're connected to something, I need to find the chain between the start and the end connector, because that's all the joints I want to create controls on, right? So here we're just using the get chain rig unit. We're taking the start connector, end connector, and we're setting all the joints that we're getting from that into the bone variable. Sweet. But what if this connector is not connected? Well, what we want is we only want the start joint, right? The joint of that start connector. And this is an important aspect of modular rigging because you want your modules to be flexible, right? I don't want to have a FK module and an FK chain module. I want one module that can do both. So here, using this optional connector, we have a module that works on a single FK or an FK chain. And that's pretty cool. So that's what we have here. Neat. For the rest of the construction, we are going to set the FK parent, which is where our FK controls are going to be parented under. And that's where we're getting our variable, our metadata. We are going to query the global control from our metadata, from the other module. I want these FK controls to be parented under the global control. So I don't need to set anything at the top level of my module. I just query the metadata and set that into the FK parent. All right, module metadata can be all sorts of types, okay? They can be queried or set on the current module, its parent, or the root module, okay? Just by specifying the namespace. And A more generic example that you can use that for would be you want to specify the left control and the right control colors. And you don't want to specify that on all your modules every time. You want to specify it at the top level on the root module, and all your other modules can query this information and just update based on that. Again, the point is you have one place to do the change, and your rig will adapt based on that. So using module metadata for this is pretty cool. And for the rest of our construction graph, we're going to spawn a control for each of our bones. Pretty simple. Obviously, we're making an FK chain. And we're also connecting our FK control shape variable here so we can change the color and the shape of our controls. And the last thing we have to do, almost there, guys, is we're setting the FK parent every time we are creating a new control. The idea is we're creating a chain, right? So these controls need to be parented under each other. So every time we create this new control, we set that to be the next FK parent. Okay? So the construction event is done. And now we need to move on to the forward solve. We want these controls to actually drive our skeleton. And we want also this awesome new attribute that we've created on the root module to drive the visibility of our FKs. So we're moving to the forward solve, very basic. Again, we're looping through the bones, we're getting the transform of our controls, and we're setting that onto the bones. It's a standard FK chain. And then we're using the metadata that we've defined in the root module to actually define their visibility. So it's pretty cool. An attribute that has been created in a different module on a different control that has been created in a different module is actually driving logic in our current module, just using this, without exposing anything. And the last thing we have to do is the backward solve. This is to benefit from the layered control rigs and also to be able to bake keys onto our controls. Here, we're simply looping through the bones, getting their transform, and setting that onto the control this time. We want to put values onto our controls and not our bones. Sweet, done. Guys, we're done. We did it. I know, I'm sorry. I'm so sorry. But look at that. We have two modules now, okay? They work with each other. They're very flexible. They work with drag and drop. And they also have a couple of attributes exposed where we can change some settings. That's pretty neat, right? So modular rigging is set to experimental in 5.4. But the tech anim team on Lego Fortnite has been actively working with the dev team to make it more stable and user-friendly. And as a matter of fact, modular rigging is actually used in production on Lego Fortnite. So we're pretty happy about this. And the other thing I wanted to say is we're actually very impressed by the community. Like, this thing just came out a few months ago, and we've seen so much cool stuff already, and people love playing with it. So we just can't wait to see what you guys come up with. This is super exciting, actually. Okay, there's actually a great documentation on modular rigging made by Chase. I really recommend to check it out. There's a bunch of stuff like the connector rules, the execution order between modules. So go for it. I'll give you the time to scan it. Sweet. And the other thing is there is some really cool content, control rig content on the Epic Games library. Okay, you just type control rig in there. There's tons of awesome videos there. And I want to point out as well, there is a Discord channel that has been created by the community, which is pretty active too. And a lot of people are, asking great questions. It's super useful. So if you want to know more about this, just let me know. All right, as I said, the toolset keeps expanding. The deformer graph now has, you are able to make the deformers in functions, turn them into functions, so you can encapsulate into functions and chain them together to create new deformer schemes. The deformers are all evaluated on the GPU. And 5.4 comes with a bunch of new deformers, dual quaternion, band, twist, flare, lattice, and more, okay? You can see this dragon's loving it. It's getting squashed and stretched and twisted. He's loving it. He's happy. He was not armed, I promise. Frederick Nielsen has been having tons of fun, basically animating a lattice deformer coupled with a control rig. So here we can see that. It's pretty neat. Thank you, Frederick. Looks pretty cool. Yeah. Sweet. Okay, as I said, there's tons of new features in 5.4. We don't have time today. I don't know where I'm. Okay, I'm pretty okay. But we don't have time today to go through all of those. But I do want to share a few snippets because, okay, there's a bunch of videos that have been made by our awesome product team, Frederick, Chase, and Greg. So feel free to check them out on the Epic Games library. I just want to share a few snippets today. And some of those are, Benoit Gadreau has done an amazing work on the new Gizmo manipulator, We now have a proper indirect manipulation with middle mouse button, a new arc-ball behavior with deterministic rotation handle, and a new parent space. Okay, here with that parent space, I'm able to animate the foot into the global control space. It's pretty neat. All right, so we also now have a new anim details that looks more like a channel box, all right? Your selection is synced to the sequencer and to the sequencer curve, so it's something that we're more familiar with. It's pretty nice, and we also have a bunch of updates on the sequencer, on what you have quick access to and what you can configure, all that here. So that's pretty nice. Sweet. Now, skeleton editor moved from experimental to beta. There's a bunch of improvements on the weight painting. You can easily now grow selection, vertex selection, and tweak the weight via the component editor. You can also pose your character or even add animation straight into the skeleton editor. Pose the animation, skin weight, paint some skin. It's pretty nice and easy. Auto retargeting for biped has been fully automated with a click of a button. The dialogue has been simplified for a quick batch retarget, and the new characterization works with a bunch of third-party skeletons. So basically, in just a few clicks, you can retarget tons of skeletons, all of this. Those are all third-party. In just a few clicks in Unreal Engine, you can retarget that. And motion matching becomes now finally production ready in 5.4. A new sample project will be shipped soon with hundreds of animations samples, so you can use that for free for your own projects. And I love this feature. It's so epic. Look at that. That looks so cool. Seriously. Just want to play with it. All right, so there's a tons of new features in 5.4 release. I've shown only what matters about animation and rigging. Please check out the release notes if you want more. And also, I'll be in the dev lounge this afternoon and tomorrow. So if you have any questions, please reach out then. I just want to say massive thank you guys for coming. I hope this talk was useful. I'm so sorry if it was a lot of controller graphs, okay? But it's almost lunchtime. It's lunchtime now. You can go have a breather. We're good. No, but thank you so much, guys. And a massive thanks to Epic as well, because it's just been a couple of months for me, but I'm so thrilled to be here and be able to share all this cool stuff with you. And yeah, just reach out. Thank you. Thanks for coming.